Okay, so we're going to work on the review sheet for your test. Right, so here it is. And it says, tell me 3 things about each type of system. Okay, remember, if we're consistent and dependent, that's when the graphs look like this. Right? We know that they have different slopes, right? They intersect only at exactly one point, right? They intersect at one point. And how many different solutions do they have? 1. A consistent dependent would look like this, because remember, it's the same line. And they intersect at an infinite number of points, right? Not just one point, like this one. And when it asks for how many solutions, these have 1 solution, and this one has an infinite number of solutions. And inconsistent lines, remember, those are lines that are what? Describe the line. Parallel. Okay? In other words, they have parallel lines, or you could also say they have the same slope. They never intersect. And there's no solution. Alright. Now then, classify each and determine the number of solutions. Guys, you can't really do that without looking at the slope of the line. You don't actually have to graph it, but you have to know the slope. They either have different slopes, same line, same slope, or parallel. So let's put them both in y equals form. So we're going to start with A. And then go to B. And all I did, guys, is I just solved for y for each one. Okay, now then I'm going to compare the 2 lines. So let's take a look at them. So I solved for y first, and then I'm going to look at the slope. So here's a slope of 2 and a slope of negative 1/3. They're not the same line, and they have different slopes. So they're going to be considered consistent, right? Independent, and 1 solution. Okay, on the next one, number 5, this one, y equals, so A is already ready. So now let's work on B a little bit. Let's solve it for y. Move the 4x over, and then divide everything by 2. When I'm comparing, they have the same slope, okay, so I know they're parallel. Then you have to check and see if they're the same line. Well, this starts at 5, and this starts at negative 3, so they don't. They're not the same line, like number 2 up here, but they are parallel, which means they're considered inconsistent, and therefore they would have no solutions, 0 solutions. Again, solve both for y, so deal with A first. Move your 6x over, and then divide by negative 2. Go to B, move your 3x over, if you look at both of these, they've got the same slope and the same y-intercept, so they are the same exact line, which means they are considered consistent, dependent, and this is number of solutions, it would be infinite. Okay, number 7 and 8 say solve by graphing. These are equal to, right? Not inequalities. So if they intersect, they will have 1 point that makes both true. Right, so you're going to solve them both for y. So this would be A and B. So A is y equals 1/2 x minus 3. When you solve B for y, you just move the 3x over. So here's your two lines. When you graph them, you're going to start at -3, and your slope is 1, 2. Be sure your line is really accurate, because when you're solving by graphing, that's the thing. You're looking for a point of intersection. It's line A. And now graph line B. Start at 4 and a slope of -3. And I found the intersection. So they intersect at right here. 2, -2. And this is classify it. Well, they just have one intersection, so they are consistent, independent. Okay, moving to number 8.